Hello, everyone. Welcome to the first day of some virtual learning. This is Mrs. Nelson. I know some of you maybe don't know me, but both Mrs. Ortman and I are going to be kind of going back and forth, doing some videos. So I'm going to take you through the lesson for today. So what you need, the materials that you need are possibly a calculator, and you will probably need a sheet of paper just to record a couple things. We're really just going to do a little bit of algebra review as it states up at the top. So what I need you to do right now is put the section title on top of your paper. You can use a notebook sheet of paper. You could use just a plain sheet of paper, whatever works best for you. And then I want you to write the essential question that says, how can I improve my understanding of algebra skills needed for success in Algebra 2B? And then today's date is March 30th. So I'll give you a second to write that down. If you need to pause before we move on, go ahead and do that. So our main goal, as it states here, is to be able to kind of work through just some different skills that you're going to need as we kind of work through some different topics in the trimester. So what you're going to do, as it says in the intro here, so I'll go ahead and highlight that so you know what I'm looking at. Okay, so right here says we're going to, before we do anything else, I'm going to have you complete as many questions as you can based on your prior knowledge. If you are unsure of how to complete a question, go ahead and circle that question so that we can reference it later. If there's something that you're struggling with, that's okay. We're just trying to get a feel for where we're at. So I'm going to have you pause, maybe take 10 minutes or so, or whenever you're finished, to resume the video, and we'll kind of check in and see how we did. I will be going through all of the questions, so after you've given it a little bit of time, go ahead and resume, and I will talk through all of the different questions. All right, so we should be back. So I'm going to start with topic 1. So topic 1 is relating to laws of exponents, and it says to simplify each expression fully. So a lot of what we've talked about, we did some work with this in Try A as well, whenever that was for you. So a lot of this should be review, and if it's not, then we'll kind of talk through it as if it isn't. So if I want to start by doing number 1, and it says we're going to take 3x squared y cubed times 4x cubed y. So this laws of exponent is going to state that as long as I have the same base, so base meaning like x here, right? And then the x here, oops, make that over the x a little bit. And then a base of y, that if we're multiplying, as it says in the middle, that we can go ahead, and the shortcut for working with the exponents is to add the exponents. The numbers get treated the exact same way that they normally would. So if I'm multiplying, the 3 and the 4 are going to get multiplied as well. So I'm going to go ahead and do that. So I'm going to take the 3 times 4, that's going to give me 12. If I have my base of x, if I have x to the second and x to the third, that tells me that I'm going to add those because we're multiplying. So my new exponent on x is going to be to the 5th. And then if I do the same thing with y, remember that if you don't see an exponent, the exponent is technically a 1. So I'm really working with y to the 4th. So that would be considered the most simplified form given the law of exponents that we have here. If I move on to number 2, division implies that instead of adding the exponents, we're going to be subtracting. So I'll maybe just put that note there. So, and again, numbers get treated the same. So 25 divided by 15, 15 doesn't go into 25 evenly. So each one of those I could just simplify as just like a typical fraction. So I'm going to end up taking each of those and dividing them by 5. So that's going to give me 5 and then 3 on the bottom. Now, if I do subtraction with my exponents, I'm going to have x to the third minus 5. And so that's actually going to give me a negative exponent. But if I think about where there are currently more x's, if I consider x to the third and x to the 5th, there would be more x's on the denominator. So this x to the negative 2 is really going to mean that there would have been an x squared at the bottom. And then lastly, if I do the same thing with my y's, so if I do my y to the 6th minus 2 power, that's going to turn out to be a y to the 4th. And again, if I use that same logic, there are more y's on the numerator, so that y to the 4th is going to stay on the numerator. So my final answer is still going to be a fraction, but I've done everything I can using the different laws of exponents. Lastly, number 3, I'll go ahead and use green for this one. So this exponent rule is essentially stating that if I have an exponent outside of another exponent, that this exponent of 3 is basically going to get multiplied by all of the other exponents that are there. Now 2 has an exponent of 1, and so does the x, so if you want to fill those in, go ahead. But essentially, we need to make sure that the 3 is being raised, or we're raising everything to the 3rd power. So I would have 2 to the 3rd power, x to the 3rd power, since there's just an exponent of 1 on x, but then the exponent on y is going to get changed to be 2 times 3, so the new exponent is going to be a 6. And then since 2 to the 3rd is a number, I'm going to just figure out what that is. So if you need a calculator, feel free to use that. Otherwise, 2 to the 3rd is 8. And then my simplified form is going to be 8x to the 3rd, y to the 6th. So those are just some basic laws of exponents, things that you may have done in the past, just maybe not recently. If you need to go back, jot some things down, feel free to pause at any point. Moving on to topic 2, this topic is relating to simplifying radicals. So basically our goal is, when we work with, in this particular case, we're working strictly with square roots. What that essentially means is I'm looking for things that essentially could be multiplied by themselves. So if I consider taking the square root of 40xy to the 3rd, I'm really looking for things that are going to be in pairs. So I'm looking for, I guess I'm going to write that note, look for pairs. So the easiest way to do that, this is the method that I like to use, is I like to draw out a factor tree, and I do the prime factorization for 40, which means I'm going to start by thinking of what are 2 things that are going to multiply to 40. So I'm going to start with maybe 4 and 10. Neither of those numbers are prime, so I'm going to break them down until I have all prime numbers. So 4 is going to be 2 times 2. 10 is going to be 2 times 5. Okay, now I'm going to maybe do the same thing with my x and my y to the 3rd. So I'm going to kind of just expand everything out. And then since I'm dealing with a square root, there we go. I'm essentially looking for things that could come in pairs. So I see a pair of 2s. There's no pair with this additional 2 and this 5. There is no pair with x, but there is a pair of y's. And anytime you circle a pair, that's essentially you saying the square root of 2 times 2, which would just be 2, and the square root of y times y, which would just be y. So those 2 items, the items that we circled, are going to essentially come to the outside and get multiplied together. So I'm going to have 2y on the outside, and then left over, I'm going to have the 2 times 5, so it's going to be 10. And then there's still going to be an x, and then there's still going to be a y left over. So the simplified form of square root of 40xy cubed is going to be 2y square root of 10xy. Okay, press pause because I was running out of some space, so I'm going to go ahead and erase it. So if you need to pause before I erase it, I'm going to work on number 5 next. All right, so for number 5, I'm going to follow a similar process. I'm going to go ahead and do the factor tree, and I'll maybe do it over here. So 16 x squared y to the 4th. Now you might look at this and say all of these represent perfect squares, which if that's an observation that you make, then that's great. So I'm gonna, if let's say you don't make that observation, I'm gonna go ahead and just break these down. So 4 times 4, which would give me 16, and then times 2 times 2. And then I can go ahead and list out the x's, and I'll just do the y's all down here. Okay, so now again, I'm looking for things that are in groups of 2. So I see a group of 2's here. I see another group, another set of 2's, another set of 2y's. So really, there won't be, unlike before when I underlined some of the items, there will not be any items left over. Everything is basically going to be simplified because 16x squared y to the 4th, everything that's in there is a perfect square. So my final answer is going to be 2 times x times y, which would really simplify to 4x y to the 2nd. So no square root left over in this one. So that's what it means to simplify a radical. Again, if you need to pause, feel free to do so before we move on to 6 and 7. Lastly, for topic 3, it says we're going to work on some combining like terms and multiplying. So essentially, when you're subtracting and you're looking for some like terms, the key thing in this process is to make sure that you first and foremost apply the subtraction, which is right here, to all of the components. So I'm going to maybe just start by rewriting this. So I have 4x squared minus 3x plus 5. And then every sign in the second set of parentheses is going to get changed. So that's going to change to minus 3x squared minus 7x. But then if I subtract a negative, that actually turns into addition. So plus 3 at the end. And then lastly, I just need to do some combining of like terms. So if I combine 4x squared and negative 3x squared, that's going to give me just a positive 1x squared. Using a different color, if I combine the negative 3x and the negative 7x, that's giving me negative 10x. And then lastly, if I combine the positive 5 with the positive 3, that's going to give me plus 8. So the fully simplified form is going to be x squared x squared minus 10x plus 8. All right, and last but not least, before you get a chance to kind of reevaluate how you did and just kind of try some things out again, last but not least, number 7, it says to simplify, and I have the quantity 2x plus 3 squared. Now keep in mind that that actually means that I'm taking 2x plus 3 and I'm multiplying it by itself. So before I go ahead and I can't distribute the exponent like I could before because there's addition in the middle. And then now I need to essentially go through and make sure that 2x gets multiplied by everything. And then the 3 also gets multiplied by everything. So if I do 2x times 2x, that's going to give me 4x squared. 2x times the positive 3 is going to give me 6x. If I now do 3 times 2x again, I have 6x again, and then plus 9 at the end. And then just like we did in number 6, if I combine the like terms, that's going to give me my final answer. So 4x squared plus 12x plus 9. All right, so those are the main topics. So I want you to kind of consider this question here. I want you to think about how you did. What do you still need to try again, revisit, and based off of that, if you are certainly welcome to do all of the sections. If not, I would suggest pausing at this point, maybe picking a section or two, or a couple of questions that you got wrong and attempting them again. I will be posting the answers to this in a separate document, so go ahead and look for that. And please make sure that when you're done with this, that you fill out the Google form for the lesson for today. So thanks for tuning in, and